Math 2, Unit 12B, Section 6. Today we're talking about systems of equations. So systems of equations are when you have two equations on the same graph and you are trying to find the points that the two graphs intersect. Okay, there are multiple ways of solving these problems, but we are going to talk about graphing them, and when you see the points they intersect, that would be an answer. And then we're also going to talk about how to solve them algebraically. Okay, so starting with A, we want to make a coordinate plane. Okay, so I'm going to go ahead and draw my X and Y axis. Okay, now, the first equation, what type of graph will that make? A parabola. Okay? So on that parabola, there's different ways of graphing it. First of all, the vertex. Do you guys know what the vertex is? What is it? I'm a little sad.
Is it negative 2 what?
You are partially correct. Okay. Okay, so the vertex on this one, since there is nothing with the x squared in terms of adding or subtracting, the x value of the vertex is 0, and the y value is the part at the end, which is 1. Okay, so 0, 1, this is my vertex. Now, what direction will this graph end up going? Up. Now, because we are trying to find the exact point that the graphs intersect, it is better to have more points that we know are true. Okay, and so what I would suggest is actually doing kind of like a T-chart, and plugging in values for x. So if this is my vertex, I could choose values like 1, 2, 3 going out. Make sense? So let's try plugging in 1. If you plug in 1 to this equation, we would have 2 times 1 squared plus 1. What is 1 squared? 1. 2 times 1 is, and 2 plus 1 makes 3. Okay? So at 1, it's going up 1, 2, 3. Okay. And because parabolas are symmetrical, that means that we know there's the same point at negative 1. Do you guys agree? Okay. So we don't have to plug it in for negative 1. We already know that value. Okay. Let's also plug it in for 2. Okay. So if I go to this equation, I'm plugging in the value for 2. 2 times 2 squared plus 3. What is 2 squared? 4. And 2 times 4 is? I just changed it. And 8 plus 1 is? 9. Okay. So 2 and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we go ahead and graph that. Okay, what type of graph is our second equation? Okay. Okay, quadratics always have a squared term in them. Does the second equation have a squared term? No. What is it going to be? A quadratic always has a square term. It's going to be a linear. It's going to be a line. Okay, how do I graph this line? Where do I go first? What's the y-intercept on that line? Okay, that 5 is your y-intercept. Good. Okay, so we're going to go up 1, 2, 3, 4, 5, make a point. Okay, and then my slope is down 2, right 1. Down 2, right 1. And we can draw our line. Now, looking at this graph right now, do you see a point of intersection? Yes. Okay, and when we're giving the answer, we are just going to be giving the x value. So what x value do these lines intersect at? 1. Okay, so we have x equals 1. If you look over here, and it's kind of not exactly perfect to see, but it's intersecting up here too. And that x value is at -2. So these would end up being my answers for A. So you're trying to find the points that they intersect. So you can see on here how they intersect at 2 places has 2 solutions. Sometimes they just intersect at the vertex and they have 1 solution. And sometimes they don't intersect at all and they have no solutions. So this one had 2 solutions. Okay, so, oh, go ahead. Sorry.
Why -2?
So right here, the point that this one intersects is right here on the x-axis. It's at -2. So we're only giving the x value. It crosses at -2 and also at 1. Okay?
Oh, okay.
Will you press the button? Okay, let's try another one. B. Okay. Robert, can you press that button for me? Okay, less talking. Okay, out of the 2 graphs, which one is the easiest to usually draw?
The second one.
The line, right? Okay, so let's go ahead and draw the line first, okay? So first of all, where is the y-intercept on this line? 0, good. Because there's nothing being added at the end, so this y-intercept, you could add a +0 if you want to. And then this slope is what? -1 over +1, because the slope in front is -1, and you can always change that to be over 1. Okay, and so from this point, I'd go down 1, right 1. And we want our graph to be accurate because we're trying to find the point of intersection. So I'm just going to make a lot of points. And remember, you can go the opposite direction. So now I can also go up 1, left 1, up 1, left 1, and so on. Okay, and I'm going to go ahead and draw that line. So now this first equation, what type of graph is that going to be? A quadratic, because it has a squared term. Now, it's important to have your vertex, and then we can plug in other values. Okay, so we always want to start with our vertex. What will be my vertex on this one? How do I find my vertex, I should say? Okay, so this one is not in vertex form, where previously in the other example it was. Do you remember how we find the x value of the vertex here? -b over 2a. So -b would be -1 over 2 times 1. So we have -1/2, or we can write that as -0.5. Okay, so in terms of my vertex, it's at -0.5. And then what do I do in order to find the y value of the vertex? Good, plug it in. So y equals -0.5 squared minus 0.5, or you could do plus -0.5 plus 3. Okay, so in your calculators, -0.5 squared is actually 0.25. Okay, minus 0.5 plus 3, and again, you can plug that all into your calculators, and you end up getting, I think, 2.75. Okay, so when you're graphing that, and I'm going to go ahead and graph that first, just like we did over here, we graphed it, and then we could see, okay, where are we going to go to the right and the left to make it symmetrical? So -0.5, and then it's up 2.75, 2.75. So it's going to be somewhere right around there. And will this curve be going up or down? Up. Okay, and so I'm just going to go ahead and draw this right now, because is there any chance of these ever intersecting? No. So this one is no solution, and I don't have to worry about getting accurate points on my parabola because it's no solution. Oops. Does everybody understand why it's no solution? Why is it no solution? Very good. They don't ever intersect. So your solution is always the point that they're intersecting. And so since this one's going up, there is no way this one they'll never cross. Okay? Are we good? Next one. Should we go ahead and do the line again first?
Yes.
Okay. So let's go ahead and draw our coordinate plane. Again, I'm going to make this kind of down here a little further. Okay. Where will I go first on my line? The y-intercept, which is positive 1. Good. Okay, now what is the slope on that line? Good, negative 2 over 1. So we're going to go down 1, 2, right 1. Down 2, right 1. And then we're going to do the same thing. Up 2, left 1. Sorry. Okay, so my line looks like this. And again, I'm doing a bunch of points. I just continue to do my slope because I want to make sure my graph is perfect when I'm trying to find a point of intersection, even though I still did not draw a very good line there. Okay, so next we are going to graph our what? What type of graph is it going to be? Good, quadratic. And the first thing we always need to do when we are graphing the quadratic is to find the vertex. Is this in vertex form right now? No. So how do we find the vertex? Good. X equals negative b divided by 2a. What is my negative b value? Negative 2 over 2 times 1, which equals negative 1, right? Negative divided by positive is a negative. Okay, I'm just going to write over here right now, though. Vertex is negative 1, and then how do I find my y value? Very good. Plug it in. So y equals negative 2 negative 2 squared. I'm going to start over. Okay. Negative 1 squared plus 2 times negative 1 plus 5. What is negative 1 squared? 1. 2 times negative 1 is? Good. Plus 5. And we simplify there, and what do we get? 4. So my vertex is at negative 1, 4. So we're going to go negative 1 up 1, 2, 3, 4. Okay. Which way will my graph go on this one? How do you know if it's going up or down?
Up.
Good. It's going to go up. Is there a chance that these are going to cross? Yeah, probably, because my curve is probably going to go out and hit it somewhere. So, what value should I plug in? What would be an easy value to the right or to the left? 0, right? Do you guys agree with 0? Okay, so at 0, what will be my x value? When you plug in 0 here, what will be the x value? Try again. 5. 0, 5. So if you're doing your t-chart, x is 0, y is 5. So 0 and then 1, 2, 3, 4, 5. Which means this one is also at 5. Does that make sense? So negative 2. Okay. You're confused? Okay, so here's your vertex, right? Yes? When you go to the right one, it's at 5, so that means that when you go to the left one, it's also going to be at 5, which happens to be the same point as on my line. I just don't draw things very good. Okay? And so they are intersecting at one point, and what x value is it there? Negative 2. So our answer is going to be x equals negative 2. Okay, let's try this next one. And again, what do we want to graph first? Our line. Okay. So the line on this one, where am I going to go first? 4, because this is my y-intercept. So up 1, 2, 3, 4. And then from there, what is my slope? Try again. What is my slope? 3 over 1. Okay, the slope's always in front of the x. Okay, so up 1, 2, 3, right 1. Or we're going to go down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Okay, so we're going to try to draw our line. Maybe you want to use a ruler. Okay, now, what will be my vertex on this one? If you were to do negative b over 2 times a, what's my b value? It's 0, right? Is there a b value? Is there a plain x term? Okay, the x value is 0. When you plug in 0, the y value is 4. Okay, so 0 up 1, 2, 3, 4. So we know that's already one of the answers, right? Okay, so I'm going to put here x equals, and we know one of the answers is 0. Now, what direction is this curve going to go? Down. So is it going to hit somewhere else?
Maybe.
Probably, yeah. So what value should I choose?
0.
We already have 0. We want to go either 1 to the right or to the left of 0. Okay, so it's up to you. I'm going to go ahead and do 1 because I like dealing with positives more than negatives. But then we'll have negative 1 once I get that answer. Does that make sense? Okay, so when we plug in 1, okay, sorry, you can't see what I'm doing. Here we go. When I plug in 1, I have negative, and then it's 1 squared plus 4. So be careful because the only thing that's being squared is the 1. And so you get negative 1 plus 4, which ends up making 3. So 1 and then up 1, 2, 3, which means that at negative 1, there's also a point at 3. Okay, because it's always like proportional. I just can't draw points good. Okay. So that wasn't exactly on something. So should we try 2 now? Yeah. Okay. So when we plug in 2, we get negative, and then I have 2 squared plus 4. 2 squared is what?
4.
So I get negative 4 plus 4, which makes 0. So at 2, we are at 0. So over here at 2, we are at 0. Still didn't touch. So should we go and try 3? Okay, let's try 3. Okay, so for 3, again, we have negative and then 3 squared plus 4. 3 squared is? So we have negative 9 plus 4, which makes? Okay, so 3 is at negative 5. So write 3 down, 1, 2, 3, 4, 5. Left 3 down, 1, 2, 3, 4, 5. And that is where they cross. So that means that answer for x is what? No. Negative 3. So remember, we're just taking the x values. And so if you go up on the x value, it's right there, which is at negative 1, 2, 3. Okay. Now, personally, I feel like graphing is more difficult than solving it algebraically, because you have to make sure you did your points right, and sometimes it goes off the graph, and to me it just seems more complicated. I think algebraically is way easier. Okay, so now we're going to do all the problems, not these, but next algebraically. Are you ready? No. This is where the fun begins. Okay. So the first thing is that we want to use substitution. Okay, where we're substituting in for y. Do you see how this one already equals y? Yes? I want to make sure both of them equal y. So what would I need to do to this one in order to make it equal to y? Good. Add 30 to both sides. I'm going to kind of do this a little weird. And so this equation ends up being y equals 12x plus 30. Is everybody okay with that? Okay. Okay, so now do we see how both of these are equal to y? So what I'm going to do is I'm going to take this right here and I'm going to plug it in for y into this equation. Or we could have done it vice versa. Does that make sense?
Yes.
So, but I always like my x squared on the left side, so I'm actually going to kind of flip this around. I'm going to write this as x squared plus 11x minus 12 equals 12x plus 30. We are just setting each of those equal to each other because both of these are solving for y. Okay? Is everybody okay with this step? Okay, what do we need to do in order to solve this? Good, you want to have it set equal to 0 and combine like terms. So I'm going to subtract 12x. And I'm also going to subtract 30. So now I have x squared minus x minus 42 equals 0. And at this point now, you can decide how you want to solve it. Do you want to factor? Do you want to use a quadratic formula? Do you want to complete the square? Albert. Wait, say that again? But then your x squared would be negative. Yeah, if you did it the other way, if you move the x squared over, it would be a negative x squared.
No, I just moved 11x.
Oh, I see. Then you have x squared equals whatever over here.
Yeah.
In order to solve for x, you take the square root, but the other side doesn't have a square, and so it'd make it really complicated. So you want to set it equal to 0. Okay, so I think factoring is the easiest if it will factor. So my multiplication number is negative 42, and my adding number is negative 1. So can you guys think of any numbers that multiply to be negative 42 and add to be negative 1?
7 and 6.
7 and 6. And specifically,
7 and negative 6.
good, negative 7, positive 6. So our shortcut here, our method works, and we just write this as x minus 7 and x plus 6. You could always do it with your grouping method that we do. You don't have to use the shortcut if you don't want to. But then when I set these equal to 0, what does x equal? 7 and negative 6. I think this is easier than graphing. I feel like it's shorter. You know it's correct as long as you know how to factor and do that stuff.
We can do like the b negative b plus or minus like.
Yes, you can also use the quadratic formula there, as long as it's set equal to 0. Okay, turn the page. We're going to do a little more practicing with this. Okay, so again, I would set it so that they both equal y. This one already has it equal to y. Do you guys see that? This one, it's saying y equals this. This one doesn't. So I'm going to subtract 80 to make it so that it is y equals x minus 80. Are we good there? Okay. So when I write this out now, you can write it how you want to. I'm going to go negative x squared minus x plus 19 equals x minus 80. Now, we want x squared to be positive. So I'm going to end up moving everything to the right. Okay? So I'm going to add x squared to both sides. I'm going to add x to both sides, and I just try to line up my like terms so it makes it easier for adding. And I'm going to subtract 19. So all I did was just move all of these to the other side so I can combine like terms. Okay, and then I would write them in descending order. So when I write this down, what am I going to start with? Positive x squared, and then what's 1x and 1x? What do those add to be?
2
plus 2x. And then negative 80 and negative 19 make equals 0. Okay, again, you can choose what method you factor, but these all end up factoring. Okay, so what's my multiplication number? Good. So we're looking for something that multiplies to be negative 99 and adds to be 2. Good. 11 and 9. And specifically, positive 11 and negative 9, because we want them to add to be positive 2. So we get x plus 11 and x minus 9 equals 0. And when you set those equal to 0, what does x equal? Perfect. Okay, the one below number 5 right now, I want you to try that on your own. If most of you get it correct, we will stop with notes there. If a lot of you get it incorrect, we're going to do another example. So, do your best. I can walk around and help, and when you get the answer, raise your hand. Okay, so I'm going to be checking answers. I need to see everybody's answers. Okay, you need to be doing the problem, not talking. Nope, wrong one. This one right here. Yeah, you're doing the one right below. But if you, I mean, I can check it. Perfect.
My God.
Oh my God.
Arthur wrote this.
Okay.
Arthur wrote this.
Connor. Yes. Nicely done. Nicely done. Yes, that's perfect. That's it. When you set equal to 0, it becomes opposite. Perfect. Oh, yeah.
That was easy.
I gave you one that was too easy.
Yeah, she goes a harder one. Oh, yeah, real quick.
No, yeah, we're done.
Oh my goodness, you guys are cheating?
No.
I was doing number 6.
They are, how is that?
Perfect. Oh, wait, is it negative or positive?
I was wondering if it was 5
It should be negative.
I can't see it.
Stop, see if you can help her figure
Oh,
it
why
out.
did you do
I could not see it. Dude, I look so weird with my glasses. I feel like so blind. Do I look like now with my glasses off? Like when I would take them off, like, you look the same. And now they're like, that's enough.
What is 6x minus 1 to 5? Yeah, correct.
Ah, you feel.
I see you like this. Well, I see you like this.
I got it wrong the first time.
I see everything. And here.
I got it right though, so we don't do it. Wait, I'm so confused.
Oh,
Everything goes around in that room. Like, I know most of the stuff like happened earlier. When I was there, I'm like, oh, I didn't know that. I should probably not say her. She knows that. She knows because that and it's so bad. I wonder if she does like
She doesn't hear anything.
I wonder how much
much stuff I believe.
All right, it looks like most of you got this right, which means this will be our last example on this set of notes. So, these are already set equal. So we have x squared plus 6x plus 7 equals x plus 3. We want it set equal to 0, so you should have subtracted x to both sides. Notice how I'm lining up my plain x term with my plain x term over here. Subtracting 3, again, see how you line them up with like terms? That makes it easier when you're combining like terms. Okay, so I have x squared plus 5x plus 4 equals 0. This number 4 is my multiplication number. So what multiplies to be 4 and adds to be 5? 4 and 1. And specifically, positive 4 and positive 1. These multiply to be 4. They add together to make 5. Okay, and so we make our parentheses. We can use our shortcut. So all I'm doing for my shortcut is I'm splitting up my x squareds. And then I have a plus 4 and a plus 1. We set those equal to 0. And when you set them equal to 0, what does x equal? And that's my answers. Okay, those are the points. What do these points represent? What do these numbers represent? The point where the two graphs cross. Good. The points where the two graphs cross. Any questions?